Welcome back to another video. We're going to be doing a problem relating to the previous problem we did in a different video, except now we have a constraint on the motion of point C. So the problem says in the problem 17.49, if the angular velocity of AB equals 2 radians per second, what clockwise angular velocity of BC will cause the vertical component of the velocity of point C to be 0? What is the resulting velocity of point C? So we need to use a related velocities equation with point C, and then we need to relate it to point B. This is because points C and B are on the same rigid body, and in the previous problem we found the velocity of point B, so we'll be referring to that term to solve for the velocity of point C. So we don't know what the x component of the velocity of point C is, but we do know that the y component will be 0. We don't know the angular velocity. We know velocity of B from the previous problem, and we know that term based on position. So the velocity of C in the I hat component plus the velocity of C in the j hat component, which we know to be 0. And then we know that the velocity of point B from the previous problem is this. And then we'll just keep the angular velocity as a symbol and make sure we put the negative sign there because it's clockwise. And then we're crossing it with the position vector from B to C. So we go to the right by 2.3 meters, we go down by 0.5 meters. So 0.5 is going to be negative. Then taking that cross product real quick, we get this expression with I and j components. And then we'll rewrite these this equation with this cross product rewritten. And then notice how we keep the angular velocity of BC as a symbol. And then we'll equate the common components of I and j and set them equal to the I and j components on the left side to have 2 equations and 2 unknowns. So right here, we're writing out the I hat component of the velocity of point C, and then setting it equal to the I hat components on the right, and then doing the same with the j hat components. So our unknowns are going to be the velocity of C in the x direction and the angular velocity of BC. Solving for the angular velocity of BC using that second equation, it will equal 2.61, and that should say radians per second, not reps per second, and it is clockwise. So since I am stating that it's clockwise, I don't have to put a negative sign there. So first they asked us what the clockwise angular velocity was, we found that. And now they want us to use that to solve for the velocity of point C with the constraint. So let's plug in the angular velocity of BC into this equation for the component of VC in the x direction. And then simple math gives us negative 9.1 meters per second. And since we know what the x component is and the y component, we can now write this velocity vector in terms of I and j hat components, which is what they want. So that is the velocity of point C with the constraint using the angular velocity that we found to be 2.61. Okay, so going back through this problem, they wanted us to find the velocity of point C when the j hat component was 0. So when it's not moving up or down, what is the x velocity of point C? And then they wanted us to find the angular velocity of the arm. I hope this video was helpful. Next time we'll be going over related accelerations.